it's generally frowned upon. And coming from healthcare and financial services, you definitely were not allowed to have real patients or real insurance customers in your test environments. That's just not acceptable. So with Flaker, you can generate from scratch a data set of a particular size, but one other way you can use it is to invoke it over an existing table because it's a function. You can just use it to substitute what's in a column already with a fake version of the same thing.
Greetings, everyone, through here. Welcome to the show. Welcome to the Demo Hub. To an exciting episode. We have a fascinating guest, an entrepreneur, a builder. He has some utilities we're going to see today, which I think is very fascinating in the modern data space. Our guest today is James Weekly. James, welcome to the show.
Thanks for having me through. It's good to be here.
Really glad to have you. Where are you calling from today?
I'm actually from a city called Newcastle in Australia, so on the east coast, just north of Sydney.
Oh, that's fascinating. I'm out in the Midwest looking outside. So it's been a sunny day, amazing weather. Can't wait to get out for a little bit of a run. So thank you for making time and joining us for the discussion today. Can you talk a little bit about yourself for the folks who don't know you before we jump into the demo aspect of the conversation today?
Yeah, sure. So my background is mainly, well, originally as a software developer, and then I moved into being a consultant and an architect in enterprise environments. And then in the last 6 or 7 years, focused on data analytics and was an early customer of Snowflake here in Australia. And I've focused on data related things, but drawing on my developer background. So I've worked for tech companies here, but I've also worked directly for financial services and healthcare companies as an employee as well. So I've shifted between tech companies and using tech within other industries. And then most recently, as you mentioned, I co founded a software company called Omnada. That's where I've been full time for the past 18 months.
That's fascinating. I think at some point we'd love to have you on the show to talk about what you're doing there in that space. But the thing we wanted to talk about today for the demonstration was I'll call it a utility or a function or library you've built called Flaker 2.0 to help with synthetic data generation. Can you talk about that and share with the audience what you've built?
Yeah, sure. Flaker is a play on words. The actual library is called Faker. It started out as a Ruby gem, I think, when I was a Ruby developer writing software tests. I got into using this library because it's good to generate a pretend customer for the test scenario that you're in. But then when I started my current company, I was doing a lot of demos of the product, and I, when you're showing people a data integration product, especially one that's for business use cases, I always like to use a data set that's similar to their own one just to make it a little more believable. So I decided to get this Faker library and actually see if I could use it to generate data directly in Snowflake. Previously, I would like run a script and it would generate a big CSV file, and then I would load it in, create a table, and it would take an hour or two to get this table ready. But I figured if I could run it within SQL, it would just populate the table from the inside. That would be much quicker. So that was how built the first version of Flaker, which was a Snowflake external function. So I had the Python Faker library sitting in an AWS Lambda, and then I would call it from a Snowflake external function. And that worked okay, but it had to, for other people to use it, you have to deploy stuff on it. It was a little bit of effort to get it up and running. So Flaker 2.0 happened once Snowflake supported Python natively on the platform. So instead of calling out to this Lambda, you can just invoke the Python directly. So Flaker 2.0 is this really simple sort of function definition that you can just create quite easily within Snowflake, and then you can be up and running using it pretty quickly.
Okay, that's really cool. And so James, are you telling me that for folks who are doing development, they shouldn't copy production into dev and develop against that? Do they really need to synthesize data?
Yeah, well, there's a few. Yeah, that's one of the main arguments for it is, I guess, if you're building things on Snowflake and you're wanting to test changes to your production system or build applications around it, it's generally frowned upon. And coming from healthcare and financial services, you definitely were not allowed to have real patients or real insurance customers in your test environments. That's just not acceptable. So with Flaker, you can generate from scratch a data set of a particular size, but one other way you can use it is to invoke it over an existing table because it's a function. You can just use it to substitute what's in a column already with a fake version of the same thing. So it's good if you want something that has the same sort of size and shape as your production database, but synthetic data, it's a good way to do that as well.
Yeah, that's really powerful. And I think this space is a very fascinating one, just given the how complex the regulatory landscape is becoming and the rules around privacy and governance. And I think really having a utility or that capability to give you synthetic data in lower environments to ensure you're meeting your compliance regulation, you're not being exposed to unnecessary risk, and the
Yeah.
team still has the data to do development is a very compelling capability.
Yeah, definitely. And people often, like when people think about data breaches with particularly with sensitive data sets, they often like to think of the outside attacker, the person who gains access to their system from the outside. But one of the more common ways it happens is just by accident internally, where people clone. It's getting easier and easier to clone production compared to what it used to be 10 years ago, especially with data warehouses. It's much easier to inadvertently share a sensitive data set with a wider audience. So I think it's more important than ever for companies to be paying attention to how people internally are using the data, and particularly if it's plugged into other systems. These days, it's common to have systems downstream of the data warehouse
Mhm.
that you don't want to be accidentally sending that test email to a million customers because you pointed a test environment at production. So these are things that people just need to have a way to mitigate that risk easily without kind of slowing down the whole process of deploying changes and testing.
Yeah, and yeah, that's a very compelling point to make there. And now we're gonna dive in deep and unpack a lot of things here and actually see a demo of it, which I'm very excited about. But can you clarify a little bit because Snowflake does have some native capabilities to generate random sequences of data. Why isn't that sufficient for a lot of the needs? And I'm guessing you have some point of views on that. Could you share that?
Yeah, Snowflake can be made to generate, sequences. You can use a lot of the built-in functionality to construct fake data that kind of resembles the domain that you're in. For example, you wanted to fake some birth dates. It's not too hard to come up with a way to generate a random date within a range, things like that. Faker goes a little beyond that, and the people that built Faker, and there's a whole community around it, have gone a little bit further to constrain. It's not just data types like numbers. I can show you an example soon
Mhm.
where if you think of latitude and longitude, a naive way to generate fake coordinates would just be to pick the range that of the whole Earth. But when you do that in Faker, for example, you can generate ones that only exist on a landmass or exist in a certain country. So it's it looks the same as something you might mock up quickly, but it's often importantly different in how it fits the constraints of the
Exactly.
real world thing. Yeah.
Yeah, and I think where you're essentially going is there is that need to generate data that looks synthetically correct, but then there's also analytical value that comes with it. Just generating random strings might give you tons of data to test maybe performance or volume. But if you're going to do analytics around that and maybe maintain referential integrity, correlated fidelity across tables with certain
Yeah.
mathematical inference around that or cardinality matching, you really need more sophistication than just random strings being generated. Really cool for folks, and we can dive in here to take a look. But you did mention something that caught my attention, and I think it's important we clarify that there is Flaker, and then you said there is Faker, which is built on
Yeah.
the Faker. Is that both built by? Is that something you build, or is one from the community and then you added on top to build?
Right. So Flaker is just a wrapper for the Faker library that runs on Snowflake.
Okay,
So that's where the play on words comes from. So yeah, I haven't actually built any fake data generation libraries myself. I've just taken a library that works well in like a Python code base and just made it so that it's wrapped it up so that it can be invoked from inside Snowflake. And yeah, that's what Flaker really is, just a Snowflake window into the existing Faker
mhm.
library. So anything that you can do in Faker for Python, you can potentially do from.
Snowflake now, so function, which is why the support for Python on Snowflake is such a huge game changer and allows for things like this, that you don't have to do that in external functions anymore. Bring that to the code
That's right.
and execute that. So let's dive in. I'm very excited to see it in action. I'm going to leave a link to this in the description below. You have an amazing Medium blog post that really outlines this, but we're going to dive right in, see a demo so for the audience that they can see what Flaker 2.0 looks like in action. Take it away, James.
Yeah, so the demo I'm going to do today, it starts off looking similar to the blog post, but I thought I would try and take it a little bit further since we have a bit more time here to explore some other possibilities. Yeah, definitely read the article, but there'll be things that I do in the demo that's not covered there. So to start off with, this is really Flake in its entirety. It's this what used to be this external function Lambda thing that you had to deploy is now just this function definition. So what it's doing is creating a function inside Snowflake, which exposes the parameters of Faker. So if I just jump back to this is the Faker library for Python, and it talks about how to use it from Python. So you don't have to worry too much about that because we're invoking it from SQL. But this is the list of providers. So Faker has this concept of providers, which are categories of fake data. So you can see it's capable out of the box of generating addresses and things relating to banks, like valid kind of Swift codes and things like that, geographic things, various things to do with internet concepts, IP address type things. And so any of these standard providers, we're going to be able to invoke through this function. And
Okay.
so,
Before we dive in there, are these providers extensible? So if I'm an organization and I have, say, a product, which is a class in itself that is unique to us, could you
yeah,
customize that to be relevant for a more
yeah,
constrained space?
yeah, definitely. So there's a lot more. I'll do a demo towards the end of an example of bringing in a third-party extension
Okay.
as well. So we'll
Okay.
cover that. And so the main parameters you have for Faker is, first of all, the locale. So this is a powerful part of Faker, which is it's not just United States English. It's if you are in Japan or France and you want to generate addresses, chances are it's going to give you something that is specific to your region, which is cool. So we pass that in first. And then the name of the provider is really just taken from this part here. I'll just zoom in a bit there. So that gets passed in there. And then providers can sometimes take parameters. So when you, within each provider, there's some variation. So anytime in Faker, like I pick one, you'll see the name of the provider and then you'll see these parameters like for file extension, the type of file we want to generate, that category would be what we pass in as a parameter. And then the function is just saying within Snowflake, we want Snowflake to spin up a Python 3.8 environment. We want it to import the Faker library. And we also use this JSON library to handle some of the type conversion. And then we're just really just importing the libraries, handling if people pass in null here, just to be friendly to them. And then really everything happens in these two lines. We're creating an instance of Faker using the locale that we passed in, and then we are telling it to use the provider and the parameters, and then whatever faker outputs, we just pass back as we return a variant. So it's a JSON structured response. So to just work through some examples, if we look at the most simple, the US English locale, we want 50 names and no parameters. So there we have just, you can see quite obviously those are American looking names, but it's funny when you start to use different locales, recognizable
Hmm.
common names from different countries, which is really cool. I'm sure a lot of effort went into that. Here's an example of something you touched on before. You could probably do some of this natively. So here's an example of dates. Snowflake's pretty good with dates. So this example is a date between, and then the parameters, the start date is 180 days ago and the end date is today. It's marginally easier to do it in Faker because you don't have to do so much kind of nested math.
Correct.
So it's a little more readable, a little bit nicer, and not impossible to do by hand.
I think what I love about that is you have this really powerful function implemented in Python. And now, as a user, I don't have to know Python to call that function and to get the power of what's
That's
behind
right.
it. And I think that's really compelling. And number two, we're not making a call to an external function. This is all running natively in
Mm.
Snowflake, which is, again, is a very compelling case.
Yeah. And if you were to build something in Python that conformed to this provider standard interface, then your SQL users would be able to invoke it as well, which is
Mhm.
cool. You just have to import the package. Here's a slightly different example of where we're taking some source data of people from different locales and different sexes, and we're passing those in dynamically to the function. One thing about Flaker is it's marked as volatile, which means that every time it's invoked on a row, it's asking for a fresh value. So there's no caching or reusing of results. So when we invoke it over this table here, we're going to have 5 different locales, and it's also taking the sex of the person on the original table as the input. What we end up with is, it's a bit hard to read because it comes back as JSON. So in this example here, we're generating data dynamically based on the input. So rather than just pure generation of X number of rows, we're saying we have these 5 people here, each from a different locale and a different sex, and that we're passing their information into the library and getting a result back that's specific to them. So you can see when we run this one here, the person from the UK has a very English looking address. And then as you work your way through the different regions, you can see like the states and postcodes and even the names of the streets resemble the locale of the person. And this is returning a full, so this is using the profile provider, and profile generates like a whole bunch of things about a person, like their company they work for, their job title, where they are, email address. So you get this full picture of a person and each part's consistent with the whole. Here's some addresses from Japan. They look legitimate to me, although I don't know. Certainly not from an English speaking country. Here's an example of barcodes. So these are EAN barcodes. I think this is another example of where on the surface they look like just 8 digits, but I think there's probably some validation, like some kind of check digit, I
Hmm.
imagine, for a barcode. Here's some user agent strings, like what you'd get from a browser. So this is these kind of things you'd often see in weblogs. The Faker library must be reasonably actively developed because cryptocurrency is a category in there. So you can generate different coins, things like that. And here's the other example I mentioned before, which is so the latitude and longitude provider, I think it's under geographical. So local lat long returns a location known to exist on land in the country specified by country code. So that's really cool. You can run that, and I've said Australia. So these are all coordinates that are on the land mass of Australia. And so that's, like you said, if the data is going to be used for some kind of visualization or some other type of app that expects the data to conform to some kind of business domain or some kind of restricted scope, this is a good way to do it. Here's an example of some file names. So I've said I want random file names in the audio category. So I've got some MP3s and some WAV files in there. But if I was to change that to say Office, it's going to generate PowerPoints and Word documents and things. We've got Swift codes, which are banking related. This is an interesting one, Lexify. So it's more of a tool of itself. So it's a shorthand way of saying, give me a certain number of random characters from a predefined list and substitute them. So I've said I only want these letters to appear, and it's substituting them at random. Another handy little shortcut way of maybe bringing your own pattern.
Yeah, you can use this for maybe obfuscating emails. Maybe the first part of the email address, you might want to hide the
Yeah.
names, but still keep the domain behind that. Like at Gmail, you
Mm.
keep that and then hide what the actual email handle is.
Yeah,
Pretty cool.
that's a good example. So that's standard providers. If you like, I could show some third-party stuff if that's of interest.
Yeah, I think yeah, we can touch on the third party stuff. And then also I know you've done some work around leveraging this not just for generating data, but also for being tied into say masking, where you want to
Mm.
generate data but anonymize an existing data set so you still maintain that fidelity to what looks like real data, but you're
Yeah.
anonymizing and masking an existing data set.
Yep. Yeah, okay. So just with the extension on the Faker website, you have these community providers. So these are ones that are written by people in specific domains.
I see biology there, life sciences. I'm guessing you can maybe
Yeah,
generate fake genomic data.
yeah, so yeah, if you click into those, so this one is actually only available as a pip package. It's not on the Anaconda channel. I've actually got a method for side loading these, which I've used in this example. I won't dig into that right now, but essentially I've downloaded the wheel file from Python from PyPy and loaded that extension in
into a
to the
stage.
onto yeah, loaded the file onto a stage. I've got a just a simple script that this isn't something that Snowflake really support or encourage, but this will take any wheel file and extract it and then add it to your path so you can use it. So this is the biology wheel and the music one as well. I grabbed them both. So I've imported those into the wrapper here. And now you mentioned cell type. I've actually got that as an example. So actually go to its homepage. So yeah, it's got biosequences like DNA and proteins and amino acids. So those are all things you can generate here. There's some cell types. I also got from the music provider just some subgenres of music, so a fair bit of variety in there. So yes, that's an example of how you could maybe the thing that you want to do exactly isn't in the main Faker provider list, but you can always go and look at the
Yeah,
third-party
some
ones before you roll your own. Yeah. And so the other thing you mentioned about dynamically applying this to a table was something I included in the end of this article. If people are familiar with masking policies in Snowflake, they're relatively new, but it's a little bit like it's how row level security works or row level filtering, except that rather than just hiding certain rows or just redacting them, you can actually replace them dynamically. So this is useful when the people that are consuming the data aren't necessarily deliberately looking to obfuscate it. So this is where an administrator might say, okay, these people can see the real data. And in a lot of cases with masking, with a lot of the examples you see, when the people who aren't allowed to see it query the same table because of the role they're using, it's usually just like a bunch of asterisks instead of the data. But what I did in this example here was create a masking policy which invokes the fake function and just says, give me a random first name. And then in a customer table, modified the first name column and told it to use that masking policy. And so what that means is when someone without the sysadmin role queries that table in behind the scenes, it's automatically invoking this faker library.
Yeah, and I think this is a very exciting tool, like you said, where typically when you do masking, you just replace with asterisks and characters that are not recognizable. But for some cases, folks might want to see a name to it, even if it's not the actual username, but just for the analytical value, having a name there as opposed to masking is relevant because if you're trying to count distinct customers, sure, you might not know who the customer is, but you might want to know that there are 10 distinct customers. And
Yes, yeah. And I guess also, depending on what is consuming the data, they have assumptions about the validity of the data. If you're doing something like a data app that analyzes geographical data, that app might be visualizing in certain ways or trying to provide insight into the coordinates that are provided. And if you just delete them, the app's not going to work. And then if
mhm.
you substitute them in with nonsensical data, it might just make the whole visualization not even work anymore or make sense. That's where sometimes there's a good middle ground.
Yeah, absolutely. I think this is exciting. And then on the back half, there are a couple of things I want to touch on. We're going to dive into AI ML piece, which I think is always fascinating to me. But the question I have for you, James, is the distribution model around this. So right now, I think you have it in GitHub for folks that want to get a handle of this. Have you
Hmm.
thought about, and I know you're very familiar with this, there is the native apps capabilities Snowflake is rolling out. And when I think about that, I think about use cases like this, right? Where it's great you can run this in your account, but if I want this functionality run in my own account, could this be something where you've thought about publishing to the marketplace as an app when that functionality is available? And I could just simply grab this, apply it without having to go write the Python code myself.
Yeah, absolutely. I think that's a huge part of the native app story is there's a lot of excitement, understandably, for these really big apps that will find their way onto the platform. But I think a lot of people will be just as excited about lots of little discrete apps and having if if everybody, say there's maybe thousands of people around the world who would use a specific type of function like this, and it takes each of them an hour or two to get it set up in their own account versus, 5 minutes clicking in the marketplace and installing it, then that's a huge productivity gain for everybody. And so I think wrapping kind of these things that are already built is going to be useful. And I think there'll be lots of little utilities like this appearing on the marketplace. But then, or say, for example, a domain specific synthetic data generator that might require somebody familiar with a particular industry, for them to publish something specific to that on the marketplace is really useful as well. And I think it's an easier way than ever for people to share their kind of analytics or data engineering type utilities.
Exactly.
Without the traditional ways like publishing a guide on how to do something and it's got all these instructions to follow and here's how to deploy it and here's how to set it up and use it. But I think the marketplace idea just wraps all that up and says, this is ready to go. Like here's the one liner that you use to get started. And I think people will be much more inclined to use something if they can get started really quickly.
Yeah, exactly. And that was exactly what came to my mind when I saw your article and read through that. Let's talk about, and maybe you know much about this than I do, a little bit more low level. Is this a rule based generation, just basic heuristics? Or do you see machine learning, AI, ML coming into play to as the next frontier for this synthetic data generation?
Yeah, there's definitely so Snowflake native apps kind of the distribution model of them has its origins in data sharing, which was originally just for providing a data set to somebody else. And then over the years, it's continued to evolve and it turned into sharing data set related functions like they do a lot now with secure collaboration, where because Snowflake is the platform in the middle, and then you have a party on either side who wants to achieve something jointly, but the idea of each showing their cards to each other is not possible, allowable. Then the data marketplace is a useful way to broker that type of thing. And an example of that would be ML. Being able to share a function that behind the scenes is making use of a proprietary ML model is a great way to have this kind of opaque insights generation. So somebody who's gone to the effort of training a model in a specific domain, this is an easy way to distribute that without risking,
Hmm.
without having to go the legal route of NDAs and IP contracts and things like that. It's more you can use this as much as you want. You're not allowed to have access to the underlying code or the what it was trained on, but you can use it, and that's really powerful. And I think that hopefully even industries that are a little more niche that maybe didn't warrant this whole maybe don't have that big of a total market because of the potential number of people who would actually use it. I think for them they'll the barrier to entry is much lower. It's simpler to deploy and distribute, and they can still make a reasonable business off the marketplace. That's what I'm looking forward to seeing more of.
Yeah, exactly. And then I think the reason why I brought that point up is because this field of synthetic data, it's a very important field, which I don't think personally gets as much attention or gravitas as it should. Because if you think about why is this relevant, really think about it in three different domains. There is a need for synthetic data when we think about pure testing. You want a lower environment, you want data in there for folks to test. But then you take it one step further and you say, why else do we need synthetic data? And you start thinking about AI ML, training
Mm.
machine learning models. So what we're realizing is that a lot of this, even Teslas of the world, what they do, and I was listening to one of the Tesla Day talks, and they were talking in there as they have tons of data, sensor data, perception data to train their self-driving cars. But they're also realizing that to really get edge cases, they need synthetic data to really help train those
Right.
models. And so that's a big space where this is really needed. And now you're going into some hardcore, deep AI ML stuff. And then you take that to the
Mm.
third dimension, which is just pure governance, right? So across just the need for testing, lower level environments, all the way to AI ML and to train models, all the way to just meeting governance and regulatory requirements, I think provides that foundation why really thinking about this and having the strategy in place is a very compelling case. And as I was thinking too, like with Faker, it's the foundation behind what you have. But I think there are other libraries out there, SDV, which is a synthetic data vault, which is based on GANs, which is the generative adversarial network. There
Right.
is the Gretel is based on a recurrent neural networks,
I
where
see.
you can train those models on your data, your existing table, to generate synthetic data based on what it's seen within your existing data set. So you can point to a production
Uh,
table, train that model based on it to say, I want you to generate synthetic data, but learn from what you're seeing in production and then generate that synthetic data based on that. And folks are building libraries to do that. And those are
mm.
things where if you do the investment to build those packages, monetize it, make it as an app in the marketplace, right? Native
Yeah.
apps, and people have to pay for it if they're gonna take that and running against their own environment. I think it's a very exciting space here to cover everything from the niche cases all the way to more advanced use cases.
Yeah. And having one thing I'm excited about with the Python support is that Python has arguably one of the biggest ecosystems of people publishing data related libraries that are open source. But for people, especially working with sensitive data, it can be a big obstacle to bring the data out of the warehouse and run this code over it in some other environment. It's a big engineering effort. It usually involves several teams. And I like the idea that the popular Python packages that people find really useful will quickly become wrapped up, SQL versions of the same thing without really a lot of effort. So that's really cool.
Yeah, that's fascinating. And as we kind of wrap up here, one of the things that I love is I'm a huge fan of AIML. I love like what the team at GPT-3 is doing. You
Mm.
literally can put in text and it can generate synthetic articles for you. That's really the next level of
Mm.
what's possible. And if they can do that with NLP and text generation, think about what you can do with enterprise data, and not just text, images. A lot of, especially in the life sciences spaces, you're working with medical images. You want to
Mm.
train machine learning models on that. You cannot use a patient's image to do that. So how do you synthetically generate those images beyond just pure strings and text to allow for your AI ML? It's a
Yeah.
huge space, and we're seeing like Dell E supporting that. The packages are coming up to do it in Python, and now those packages could be run in Snowflake, and you can do that natively. It's
Yeah.
just a mind blow as we think about this.
Yeah. Yeah, definitely. And I think it's early days
Hmm.
in we've had 10 years of development in all these, more recent areas of AI, but I think the convenient distribution of them, it's very early days in that
Hmm.
space.
Yeah, yeah. I think the with something like Snowflake and the simplicity and having that avenue to bring it to the masses, right? So this is really the avenue of bringing AI to the masses, where no
Mm.
matter how complicated that function is, like what you just showed and how simple it is, behind the scenes, as a user, I can just call that function just with pure SQL, and you could be using Faker, you could be using GANs, you could be using RNN, what you could use any
Mm.
amazing Python stuff behind it. But to that end user, from their perspective, it's just SQL they're calling, and it just makes that distribution a lot frictionless. So I'm very excited by this, and it's such an exciting piece. Where can folks find? I think we have the link to the article here, which we can leave in the description below. What other resources are available, and where can folks find that or find you, James?
Yeah, so the Medium article is a good place to start. It has a link to the Git repository that describes it or that shows you a bit more concisely how to set it up. And yeah, folks can find me probably the easiest way is on LinkedIn. Just search for me there, add me. I'm in a few different Slack communities that you might already be in, but LinkedIn's often a good place to start. And yeah, I'm interested in talking about this stuff. So yeah, if anyone's got questions or ideas, feel free to reach out.
Awesome. That's very fascinating, James. I'm a huge fan. I was just very elated to see this product. And thank you for coming on board to the demo hub and demoing that and showing that to the community. And as we were chatting before the call, you're also the founder of Obnala. I think I've extended that invite to have you come on board and do a full deep dive and a demo of that. So hopefully that invitation is accepted and we get to do a demo of Obnala too as well and a conversation around that.
Yep, sounds good.
All right. Thanks, James.
Thanks, Rue.
All right. Okay.